Welcome to Math with Professor V. In this video, I will be working through and solving the most recent exam I gave my Calculus 2 class. It was on integration techniques, arc length, and area of a surface of revolution. So I'm just going to go through pretty quickly and work through the problems, but if you need more of a full-length video lecture on any of the techniques or topics covered in the exam, they are all linked in the description below. Okay, first one, evaluate the integral. A few students went in and did trig sub right away, but the majority did a u sub first, so that's how I'll do it. We're going to go ahead, let u equal, that's right, e to the x, and then du would be e to the x dx, which we have right here. Then change your limits of integration. So u of 0 would be e to the 0, which is 1, and then u of natural log of 4 is e to the ln of 4, which is 4. So the integral becomes 1 to 4 du over square root u squared plus 1. Now we can do trig sub, but alternatively, some people just let e to the x equal tan theta. You know what I mean? So yeah, we're going to let u be tangent theta. Then du is going to be secant squared theta d theta. And then from here, we also have to change our limits of integration. Now these limits here, 1 and 4, belong to the variable of the integral, which is u. So 4 equals tangent of theta, and 1 equals tangent of theta. So that means theta is, oh, this isn't anything nice that we know from the unit circle, tan inverse of 4. And then in the other case, theta is, that's right, pi over 4. So my new integral becomes pi over 4 to tan inverse of 4. And then du in the numerator, that's secant squared theta d theta, over the denominator is going to be square root tan squared theta plus 1. Well, we know we're going to replace that with secant squared theta. Taking the square root of it means it's just secant theta, technically absolute value, but we restrict where theta is, so we don't have to worry about the absolute value. So then all we're left with now to integrate is secant theta d theta. So that antiderivative is ln, absolute value secant theta plus tan theta. And we're evaluating it from pi over 4 to tan inverse of 4. Very good. Okay, then from here we have ln, absolute value secant of tan inverse of 4 plus tangent of tan inverse of 4 minus ln, absolute value secant of pi over 4, that's rad 2, and tangent of pi over 4 is 1. Okay, now to evaluate secant of tan inverse of 4, remember, anytime you see an inverse trig function, that just represents some angle. So that's the same as saying tangent of theta is 4, meaning the ratio of opposite over adjacent is 4 over 1. And this side here would be square root of 17. So I need natural log, absolute value, secant of that angle would be ratio of hypotenuse over adjacent. So that's going to be rad 17 plus, and then this will just give me back 4. Minus ln. Now I could just switch to parentheses on all these, right? So this is ln rad 17 plus 4 minus ln rad 2 plus 1. Okay, very good. Beautiful. That one's done and dusted. Okay, moving on. Next question. This was classic partial fraction decomposition. So I already gave the denominator factored. That way they didn't waste too much time. I just want to see, can they do partial fractions? So we'll have a over x minus 1, that's a linear factor, and then you need bx plus c, since x squared plus 9 is an irreducible quadratic. Then you're going to multiply everything through by the LCD, so you get 10 equals a times x squared plus 9 plus bx plus c times x minus 1. So 10 equals ax squared plus 9a plus, and then this will be bx squared minus bx plus cx minus c. And then we'll solve for the constants by equating coefficients of like terms. So x squared, there's no x squareds on the left, so that has to equal a plus b. X to the first, none on the left, that must equal negative b plus c. And then x to the 0, my constant, I have 10 equals 9a minus c. Okay. So what I'm going to do actually is add the first two equations together, then b will be eliminated, and I have 0 equals a plus c. And then I'm going to add that to the last equation, 10 equals 9a minus c, which gives me 10 equals 10a. So A is 1, B is negative 1, and then C is going to be, if you go back here, negative 1 also. Yes? Very good. So we have integral A over x minus 1 plus bx, so plus negative x minus 1 over x squared plus 9. Now the key is you got to split up the last term into two terms. So we have integral 1 over x minus 1 minus x over x squared plus 9 minus 1 over x squared plus 9 dx. So antiderivative here is going to be ln absolute value x minus 1. A lot of them now don't need to do an actual u sub. They just know it's 1/2 ln the denominator minus, and then this is 1/3 tan inverse x over 3 plus c. Oh, c, not 3. They rhyme, but they're not the same. Okay, good. No, I wanted a rectangle. Much better. Okay, that one was super straightforward. Next one, we have arctan of the square root of x dx. So I'm going to start off by making a substitution. I'm going to let t equal the square root of x. Then t squared is equal to x. So 2t dt is dx. So then the integral becomes arctan of t. And then instead of dx, I have 2t dt. Now we can do integration by parts. So I'm going to let u be the inverse trig function, so arctan of t, and then dv is going to be 2t dt. So derivative of arctan t would be 1 over 1 plus t squared dt, and then v would be t squared. So let's apply our by parts formula. We have t squared arctan of t minus integral t squared over 1 plus t squared dt. And then I've shown them this trick so you don't have to do long division. You just add 1, subtract 1 to the integrand. So we still have this t squared arctan of t out here minus integral. Then this t squared plus 1 over the denominator is just going to be 1 minus, and then you have 1 over 1 plus t squared dt. And then we're done. So t squared arctan of t minus t plus, oh, let me keep writing arctan because that's how the problem is. Plus arctan of t plus c, and then you got to go back. So t was square root of x. So square root of x squared, that's just going to be x. Arctan rad x minus rad x plus arctan rad x plus c. Good? Great. Okay, next one. This one you have to make a u sub first, and then you do partial fractions. Hopefully like this little secant squared t dt is screaming at you. Let u be tan t, then du is secant squared t dt. So then your integral becomes du over u squared plus 3u plus 2. So it's partial fraction time. So this is just going to be two linear factors, really relaxing. So we'll have a over u plus 2 plus b over u plus 1. So 1 equals a times u plus 1 plus b times u plus 2. Now this you don't have to multiply out. You could just substitute in. Since we have all, linear factors, let u be negative 1. So 1 equals a times 0 plus b times 1. So then I know, okay, b is 1. And then let u be negative 2. Then I have 1 equals a times negative 1 plus b times 0. So then a is negative 1. So then we can rewrite our integral. And I'll have a is negative 1 over u plus 2 plus b is positive 1 over u plus 1 du. Let me put the positive one first, Let's put our best foot forward. So ln, absolute value of each of the denominators. And then remember, u was tangent t. And some of them combined it into a single logarithm. Some left it. I don't really care. As long as you get to here, we're good. It was t, right? Yeah, perfect. Okay, very good. Moving on. This one I gave him a hint that first you needed to do long division because notice the bottom is not of a higher degree. So that's always the rule of thumb. So we have x cubed. You could put placeholders, but this one kind of works out if you don't. So, why do it? If you don't have to, why do it? So we'll divide denominator into the numerator. So just look at the leading terms. What do I have to multiply x cubed by to make it 5x to the fourth? 5x. Then distribute. So that's 5x to the fourth plus 25x squared. Subtract. And then I just have this remainder now of 5. You bring it down. So the integral becomes 5x plus 5 over, and then x cubed plus 5x, I could take an x out, and it's x squared plus 5, like this. Good? So on this portion here, we need to do partial fractions. So 5 over x times x squared plus 5. So you'll have a over x, that's a linear factor, and then bx plus c over x squared plus 5, since that's an irreducible quadratic. So multiplying everything out, this will be ax squared plus 5a plus bx squared plus cx. And then let's see, for the x squared terms, there aren't any on the left, so 0 equals a plus b. X to the first, there aren't any, so c is 0. And then my constant term, that tells me a is 1. So then b is negative 1. And then we're pretty much done. So here's our integral. 5x plus 1 over x minus b is 1x over x squared plus 5. Are we good? We're great, Professor V. Okay, perfect. So then from here, take the antiderivative. That'll be 5 halves x squared plus ln, absolute value of x, minus 1 half ln, I don't need absolute value for the denominator, plus c. Okay, perfect. Evaluate the improper integral or state that it is divergent. The absolute first thing you need to do is rewrite it as a limit. This is limit as t goes to negative infinity, t to 0, y over, and then the key here is to write y squared squared as y to the fourth dy. Then hopefully you can see you're going to make a substitution. You're going to let u be y squared, and then du is 2y dy, so 1 half du is y dy. And then my limits of integration will change as well. So we've got limit, t goes to negative infinity, it'll be t squared, this is still 0. And then I have 1 half du over u squared plus 4. So that antiderivative is going to be tan inverse, good. So I'll have limit, t goes to negative infinity, 1 half, another 1 half, tan inverse u over 2, evaluated from t squared to 0. You guys, let's just take this 1/4 out. It's bothering me. Limit, t goes to negative infinity. Then this will be tan inverse of 0 over 2 minus tan inverse t squared over 2. Okay, so tan inverse of 0, that's just 0. And then as t goes to negative infinity, t squared's going to positive infinity. Dividing by 2 still, it's going to positive infinity. So this is going to approach pi over 2. You should know that from the graph. So then I have 1/4 times negative pi over 2. So this is going to be negative pi over 8. Good? Okay, so it's convergent. We can add that in there. Why not? All right, moving on. Evaluate the improper integral or state that it is divergent. So why is this one improper? Because of that lower limit of 0. So you need to rewrite it. Limit, pick your favorite variable. I'll say a goes to 0 from the right, a to ln of 3, x to the negative third, e raised to the x to the negative second, dx. Now I totally let them, if they just wanted to get the antiderivative nice and clean, and then plop everything back in. So the notation's not so tedious. They could write consider an indefinite integral. And then you could do the u sub here. So let u be x to the negative second. Then du would be negative 2x to the negative third dx. So this is going to be negative 1 half integral e to the u du, which is negative 1 half e to the x to the negative second plus c. And then you can kind of just like put it all back together and say, so we have the limit as a goes to 0 from the right, negative 1 half, and then e to the x to the negative second evaluated from a to ln of 3. That just kind of makes the process easier so you don't write lim and have to change the limit so much. Okay, so then you have limit, a goes to 0 from the right. Keep this negative 1/2 out of the mix. So you have e to the ln of 3 to the negative second. No, you can't use your logarithm properties because this negative 2 applies to the whole logarithm, not just the argument. So leave it alone. Minus e to the a to the negative second. I'm going to write it as 1 over a squared, okay? Now watch this. That was really the key. If a goes to 0 from the right, 1 over a squared is approaching positive infinity. And e raised to something getting very large is also going to infinity. This is some constant. I don't care what it is, but a constant minus something getting very large, this is all going to negative infinity times a negative 1/2. This overall limit is positive infinity. They needed to identify the limit correctly. So since the limit approaches infinity, not some finite number, then we say this improper integral diverges. Okay, good. One more improper integral. This time they needed to use the comparison theorem. So in this case, I'm going to compare it with p series where p equals 1. So the integral from 1 to infinity, 1 over x dx. We know that this diverges because p is equal to 1, x to the first. And so I need to show that my integrand, x plus 1 over square root x to the 4th minus x is greater than or equal to 1 over x. Can I do it? Let's see. Probably, because I told them to. So x plus 1 over square root x to the 4th minus x, that's greater than or equal to x over, right? Square root of x to the 4th minus x, which is also greater than or equal to x over square root of x to the 4th. And this just simplifies to x over x squared, which is 1 over x. So yep, I did it. So then you have to just summarize by the comparison theorem. The integral from 1 to infinity, x plus 1 over square root x to the 4th minus x dx diverges also. So for full credit, you would have to state what you're comparing it to, why we know it diverges, it's a p series, p equals 1, and that the limits of integration are 1 to infinity, just like what we have here. And then you need to clearly show this series of inequalities to justify that our integrand is bigger than 1 over x. Okay. Oh, find the exact length of the curve. So Arclength formula is going to be integral a to b or c to d, whatever. And then 1 plus, since we have a function of y, this will be x prime squared, and then we're integrating with respect to y. The key for this guy is distribute first, otherwise you're going to be in a world of hurt. So this is 1/3 y to the 3/2 minus y to the 1/2, right? Okay, so x prime is going to be 1/2 y to the 1/2 minus 1/2 y to the negative 1/2. Then let me square this, square it. It'll become 1/4 y minus 2 times the product of 1/2 y to the 1/2, 1/2 y to the negative 1/2 is just going to give me negative 1/2 plus 1/4 y to the negative first. And then I have to add 1. So x prime squared plus 1, that negative 1/2 will become now positive 1/2. And then the clincher to integrating is that you factor this back into 1/2 y to the 1/2 plus 1/2 y to the negative 1/2, like that, squared. So then arc length is going to be integral, what were the limits? 1 to 9, 1/2 y to the 1/2 plus 1/2 y to the negative 1/2 dy. I really recommend take that 1/2 out. It'll make integrating so much easier. So add 1 to the exponent, divide by the new exponent. Remember, I took the 1/2 out on the other one, so it'll be y to the positive 1/2, and I'll have a 2 in the front, yes? Yes, okay, 1/2, 2/3, 9 to the 3/2, that's 27 plus 2 times 3 is 6, minus 2/3 minus 2. So what is this going to be? Should I leave it as, yeah, let's do that. So this is 54 minus 2 is 52 over 3. 1/2 52 over 3 plus 4 plus 12 over 3. That's 64 over 3. 1/2 times 64 over 3, 32 over 3. Okay. Good. I think there's one more surface area problem. Yes, the given curve is rotated about the y-axis. Find the area of the resulting surface. So in this case, if we're spinning around the y-axis, surface area is 2 pi. Radius would be given by x, and then you have your arc length, ds. So in this case, since x is a function of y, ds is going to be square root 1 plus x prime, or dx dy squared dy. Okay? And we'll go 0 to a over 2. So dx dy, let's see. I taught them the shortcut. If you have derivative of square root something, you put 2, the original radical, in the denominator, and then you do the chain rule up top. So this will just be negative y over square root a squared minus y squared, and then square it, dx dy squared. Now you just have positive y over a squared minus y squared. No more radical. Okay, I feel good about that. So 2 pi integral 0 to a over 2. Now this x, I'm not going to leave it as x in the integral. I'm going to replace it with square root a squared minus y squared. How do I know to do that? Because we're integrating with respect to y, so I can't have any x's in there. You're not in Calc 3 yet. And then ds is going to be square root 1 plus dx dy squared, which is right here, y over a squared minus y squared dy. Now here's the fun part. You're going to put everything that's underneath the radical together. So you have one big square root, and then you're going to have a squared minus y squared, and then that distributes to 1 plus y over a squared minus y squared, like that. And then look, cute. Distribute your little heart out. So then this is 2 pi 0 to a over 2 square root a squared minus y squared plus, I forgot to square this. Holy smokes, that would have ruined everything. Squared y squared. Okay. I was like, I know they should cancel. There we go. Okay, so then that's going to be 2 pi integral 0 to a over 2 a dy. And then you're going to have 2 pi times a times y, evaluated from 0 to a over 2. So that's 2 pi a times a over 2, which is pi a squared. Boom. Okay, last one, extra credit. It was all or nothing. Evaluate the following integral. The key is to split it into 2. So you're going to write it as x plus 7 squared tan inverse 5x over 25x squared plus 1 times x plus 7 squared plus, and then the other one I'm already going to take an x out, and then you have 25x squared plus 1 over, there it is again, 25x squared plus 1, x plus 7 squared dx. Okay, so we'll tackle them one at a time. The first one, boom, that cancels. So we could just do a cute little u sub. I'm going to let u be tan inverse of 5x. And then here's the part people miss the most that made me sad. Derivative of tan inverse of something is 1 plus the something squared. And then you have to do the chain rule, multiply by the derivative of 5x. So there should be a 5 up top. I know. So 1/5 du is 1 over 1 plus 25x squared dx. So this is actually going to be, yeah, I know, 1/5 integral u du. So it'll be 1/10 u squared plus c1, which would be 1/10 tan inverse 5x squared plus c1. Then integral number 2, this just cancels. And then you could do the little shortcut if you don't want to do partial fractions, because you have x over x plus 7 squared, right? I'm always looking for the quickest way to do something. Add 7 minus 7. Then look what happens. You have x plus 7 over x plus 7 squared minus 7 over x plus 7 squared dx. Boom. So this is integral 1 over x plus 7 minus 7 over x plus 7 squared. And then now you should be good to go, right? Yes. So this is ln absolute value x plus 7. This is to the negative second. So add 1, divide by the new exponent. It'll be plus 7 over x plus 7. And I'll say plus c2. So altogether, you have 1/10 tan inverse 5x squared plus ln absolute value x plus 7 plus 7 over x plus 7 plus c, where c is c1 plus c2. Okay, I know that was like really fast and furious. My husband has a work call to make, so he was like, hurry it up and get this over with. And I also wanted to get this video out today because my class is going to get their exams handed back, and I wanted them to have the solutions available in case they were curious. So that concludes the video. I'm not normally so turbo speed, so if you want to watch something where I'm not speed running through an exam, check out the video lectures that are linked in the description. I'm also losing my voice, so I'm trying not to talk too much, but here we go. I really made this video for my students, not so much the general public, but if it helps anybody, so be it. I love you all. Thank you so much for your support, and when I come back, hopefully my voice is back and I'll be on normal speed. I love you guys so much. Give the video a thumbs up. Follow me on Instagram and TikTok, Math with Professor V. Bye.